Hello, and welcome to the Galaxy Scientist. I'm so glad our paths crossed in this quiet space tonight. Wherever you are in the world, allow the gentle darkness to gather around you like a soft blanket. Let the hurried thoughts of the day simply drift away, much like distant, unnamed comets silently leaving our solar system. In this stillness, we'll turn our gaze toward the vast, beautiful canvas above us. Tonight, we're going to whisper about some of the most fascinating phenomena woven into the very fabric of the universe. The strange, the marvelous, and the wonderfully unexpected discoveries that remind us how much we still have left to explore. We'll move at the speed of moonlight, without any rush, letting our minds settle and our curiosity stretch out like an ancient star map. If this calm journey through science brings a little ease to your evening or gently sparks a question in your mind, please consider leaving a soft like and a quiet subscribe. It's the gentle current that helps others find this peaceful corner, too. For now, settle in. We'll begin our journey, unhurried and warm. The universe, in its infinite embrace, is a structure of breathtaking intricacy. It is not merely a collection of objects, but a grand, elaborate tapestry woven from the very fabric of existence. Every single thread, from the tiniest unseen particles dancing in the quantum foam to the colossal galactic superclusters that span across the velvet dark, is guided by a silent, invisible rhythm. These are the inviolate physical laws, the ancient rules that have held the cosmos together since the first breath of time. They are the quiet heartbeat of everything we know, steady and unchanging. Yet, there are moments in this vast expanse when the conditions align in ways that feel almost miraculous. When the external pressures of the void meet the internal peculiarities of matter, the universe creates something truly extraordinary. It births objects of such beauty and strangeness that they defy our simplest imaginations. Tonight, we drift towards these wonders. We will gently float past them, observing the oddities and the marvels that lie hidden in the deep. Our path is one of slow discovery. We will eventually find ourselves drifting near the glowing cradle of the Orion Nebula, a place where stars are born from the dust. Later, in the quiet distance, we will acknowledge the presence of a heavyweight of the cosmos, a black hole, resting closer to our home than you might think, a silent guardian of gravity. As we float further, we will brush past worlds that orbit other suns' exoplanets, with skies and surfaces so unusual they seem pulled from a dream. And deeper still, we will let ourselves sink into the obsidian waters of interstellar space to find the lonely wanderers, the rogue planets that travel without a star to call home. Our gaze will stretch beyond the familiar spiral of our Milky Way, out to where galaxies twist into bizarre shapes, and finally, into the profound silence of the supervoids. But for now, let us settle. Let us begin where the light is softest. Imagine the vastness of outer space not as empty, but as a canvas waiting for paint. Scattered richly across our galaxy, like splashes of ink on parchment, are the Magellanic Clouds and the great nebulae. Some are modest, tucked away in quiet corners of the sky. Others are immense, stretching their ethereal arms for tens, even hundreds of light years, creating monuments of gas and dust that dwarf our entire solar system. These are the nebulae, vast, floating islands of interstellar material. In these clouds, a slow, patient magic is at work. Gravity, the great sculptor of the universe, begins to pull. It is an inexorable force, gentle at first, but unyielding. It draws the gas and dust inward, compressing it, folding it over on itself, tighter and tighter, preparing for the moment of ignition. Most of these tremendous clouds remain shy, barely visible against the deep, dark abyss of space, hiding their work in the shadows. But there are a few, blessed by starlight, that can be seen even from our little blue world. If you look up on a clear, crisp night, away from the city lights, your own eyes can find them. One such jewel, perhaps the most beloved of them all, is the Orion Nebula. It rests about 1,344 light-years away from where you lay tonight, a distance that sounds vast, yet in the scale of the galaxy, it is like a neighbor's lantern flickering down the road. It sits perfectly in the constellation of Orion, the Hunter. You may know his belt, those 3 bright stars in a row. But if you look just below, you will see the Sword of Orion. It appears as a clearly visible line, formed by 3 relatively bright points of light. The middle point of that sword is not a single star, but a fuzzy, glowing patch. That is the nebula. Because of its immense size and its comparative closeness to Earth, this nebula has been a source of wonder. For as long as humans have looked up and wondered, it has whispered to astronomers since the very early days of stargazing, inviting them to look closer, to understand the fires burning within its heart. It is hardly surprising, then, that this great, glowing structure is one of the best studied objects in our night sky. We have watched it for centuries, but it was only recently that we truly saw it in all its glory. It was in the year 1993 that the Hubble Space Telescope, floating high above our atmosphere, turned its lens toward this cosmic nursery. The images it beamed back were not just data, they were masterpieces. For the first time, the rich diversity of its colors could be truly appreciated. Imagine a painting made of light hues of deep, passionate reddish pinks and soothing bluish purples swirling together. These colors tell the story of the elements, the red whispers of hydrogen, the blue of heat and reflection. But there was a mystery here, too. In the spectral analysis of the light, nestled among the familiar reds and blues, were unusual, bright green lines shining from the peripheral areas of the nebula. This strange, emerald glow perplexed scientists for a long time. It was a riddle written in light when they analyzed this radiation. It did not match the fingerprint of any chemical element known on Earth at the time. It was a ghost in the machine, a color that shouldn't exist. The mystery was so profound that a hypothesis was put forward, suggesting that perhaps space held elements we had never seen. They gave this hypothetical element a name, nebulium. It was a romantic idea, an element argued to be absent from our rocky planet, but allegedly amply scattered across the clouds of deep space, a special building block of the stars. It felt like magic. However, the universe often holds answers that are simpler, yet more profound than our wildest guesses. With the advancement of science and our understanding of the atom, the ghost was revealed. It turned out that nebulium was not a new element at all. That beautiful green light was being emitted by something very familiar, yet existing in a state we rarely see. It was oxygen, but not the oxygen you are breathing in right now. Soft and cool. This was doubly ionized oxygen, existing in an extremely rarefied state, meaning the atoms were spread so thin, so far apart in the vacuum, that they could glow in a way they never could on Earth. This discovery was a quiet triumph. It accounted not only for the bizarre illumination of the Orion Nebula, but solved the riddle of the green ghosts in planetary nebulae across the cosmos. It was a reminder that the familiar can become magical when given enough space to shine. Within this glowing cavern of gas, life is stirring. The Orion Nebula is a bustling nursery. Including our own star, the Sun, as a distant relative, there are currently not less than 3,000 stars that have been discovered within the embrace of the Orion Nebula to date. It is a crowded, energetic family. Alongside these shining stars, there are giant, dense clouds of interstellar gas and a great number of protostars, stars that are still in the process of waking up, gathering their strength, wrapping themselves in blankets of dust as they prepare to shine. All this amazing diversity of space objects, the finished stars, the infant stars, the wisps of gas, is concentrated in an area of around 23 light-years in diameter. It is a pocket of intense creation, and nothing here is static. Everything is in motion, all of them continuously and elaborately interacting with each other. The gravity of one star nudges the dust of another. The light of a giant pushes against the clouds. It is a dance of creation on a massive scale. If we could weigh it all, the overall mass of the material concentrated here would be staggering around 10,000 times the mass of our own Sunday. Let us drift deeper now, moving past the outer veils of dust, looking at the Orion Nebula closer. As our eyes adjust to the brilliance, we will notice several clearly defined areas within the glow. The most outstanding of them, the jewel in the crown, is known as the trapezium. It is named for its shape, like a small, imperfect geometric form sketched in light. Also known by its catalog name, Theta 1 Orionis. This is an open star cluster. In cosmic terms, it is an infant only about 300,000 years of age. To the universe, that is less than a blink of an eye. The cluster is made up of 8 main components, a small gathering of giants. Some of them are binary stars, pairs of suns waltzing around a common center of gravity, forever bound to one another. Others are solitary wanderers, having no companions, reigning alone in their patch of space. The brightest and most noticeable of the trapezium stars are 4 stellar systems. They are the pillars of this temple, designated simply by letters of the Latin alphabet, A, B, C, and D. Located close to each other, huddled for warmth in the vast cold, they lie within an area about 1.5 light-years in diameter. It is a tight, intimate circle. These are not average stars. They are titans. Each of these objects' mass lies within 15 to 40 solar masses. This means that these stars are quite young, voracious, and incredibly hot. They burn with a ferocity that defines their short, brilliant lives. Among them, one stands as the undisputed king. Theta 1 Orionis C is the most massive, as well as the brightest star in both the trapezium cluster and, actually, the entire nebula. It is a true giant, a white and blue main sequence star. Its mass is roughly 40 solar masses, a weight we can barely comprehend. Its size is equally impressive, with a radius that is 8 times that of our own Sunday. But it is the heat that truly sets it apart. The object's surface temperature sizzles at approximately 45,000 Kelvin. To compare, our Sun is a gentle 5,000 Kelvin, and its light, its luminosity is about 250,000 times higher than that of the Sunday. It shines with such intensity that it acts as a lighthouse for the entire region. The radiation of Theta 1 Orionis C is so powerful that it illumines virtually all the nebula around it. It is the reason we can see the Orion Nebula glowing in the dark. It is the bulb within the lampshade. But if you were to float close to this star, you would notice something strange. There is hardly any interstellar gas in its immediate vicinity. You might expect a nursery to be cluttered with dust, but here the space is clear, almost pristine. This is not by accident. This is the case due to the fact that it is typical for objects of this class to experience exceptionally powerful stellar wind. Imagine a gale force wind, but made of light and charged particles, blowing continuously from the star's surface. It is a force of nature that sweeps the area clean, pushing away the clouds, creating a bubble of clarity in the fog, and scattering the rarefied material far off into the deep. Drifting away from the brilliant glare of the trapezium, we allow ourselves to float a few light years across the velvet darkness. Here, the intense winds begin to settle, and we find another remarkable family of stars, known as Theta 2 Orionis. It is a trio of siblings, 3 gravitationally bound stars huddled together near a magnificent structure called the Orion Bar. Imagine a ridge in the landscape of space, an extensive, glowing cliff of hot gas that carves a line through the dark. For a long time, this ridge was a secret kept by the universe. Dense clouds of dust acted as heavy curtains, hiding the wonders behind it from our curious eyes. But technology has given us new ways to see. The James Webb Space Telescope, with its golden mirrors, peered through the dust like a lantern cutting through fog, beaming back images of breathtaking detail, revealing the hidden heart of this region. In this system, the first star we meet is a gentle giant. It is just slightly less massive, and not quite as luminous as the king of the trapezium we left behind. Yet it burns with a fierce beauty, its surface temperature measuring about 35,000 Kelvin. Its companion, the second component of the system, is a heavyweight in its own right, holding a mass 15 times that of our own sun and shining with a brilliance 12,000 times brighter. And the third, the smallest of the trio, still commands respect with a mass equal to 5 suns, its surface glowing at nearly 14,000 Kelvin. They dance together in the quiet, a shining beacon near the great bar of gas. However, it wasn't just these bright beacons that caught the researchers' attention when the new images arrived. The infrared cameras of the James Webb Telescope allowed us to look deeper, past the glare, to detect previously unseen objects hidden deep within the protective folds of the gas and dust clouds. It was like finding pearls hidden in the sand. Thanks to this vision, about 180 so-called proplets have been discovered at the heart of the Orion Nebula. These are not stars as we know them yet. They are the cocoons. They are dense, dark, protoplanetary disks surrounding stars that are still in the delicate process of formation. They are the promise of future worlds. One of these, catalogued with the name Orion, 294 to 606, is a mere infant in cosmic time. It is a dark silhouette against the bright nebula, a young star surrounded by a disk of gas and dust that stretches about 300 astronomical units in diameter. Because it lies at an angle to Earth, we can observe its structure clearly, seeing the shadow of the disk where planets may one day be born. It is expected that this young object will fully wake up and hit the main sequence phase in a few million years. When it does, it will likely be accompanied by a family of its own, a system of several exoplanets and possibly their circling moons. Let your imagination drift to the surface of those future worlds, eons from now. The night sky of these future celestial bodies must be a truly fantastic sight. Just imagine looking up not at a black void, but at a multicolored, luminous veil. The glow of a multitude of close and bright stars, far more numerous and brilliant than those we see from Earth, would pierce through the clouds, and every now and then, tremendous swirls of glowing gas would sweep across, covering half the sky, turning the deep night into a soft, translucent twilight that never truly fades. If we fly a little further, letting the currents of space carry us, and examine the wider region, we see that the bulk of the nebula is filled with scattered gas. It is a cosmic ocean. The central part of this cloud is filled with highly ionized hydrogen, a gas that has been energized by the starlight, actively absorbing the high-energy radiation from the giants nearby. The temperature here is intense, reaching 10,000 Kelvin. But as we drift towards the edge of the region, the heat fades, dropping sharply into the cold of the void. This contrast between the searing heat and the freezing cold, between high pressure and the vacuum, creates a weather system on a galactic scale. The collision of stellar wind streams sets the material in space in motion, creating tremendous currents and vortices. According to calculations, some of these silent winds can reach speeds of up to 50 kilometers per second. These are not small breezes. Their size can be greater than our entire solar system, swirling in the dark. Also, in some quiet corners of the nebula, thin strands stretching for several light years have been detected. These delicate filaments consist of relatively cool molecular hydrogen, pure and simple, existing without the mixtures of methane, ethane, or water found elsewhere. They are the simple threads of the universe's tapestry. Further out, as our view widens, we will see that the central, burning region of the Orion Nebula is enveloped in a vast, protective embrace, a cloud of cooler, denser gas. Here, the light and the dark dance together. The cloud of bright stars and the luminescence of ionized hydrogen intricately intertwine, creating a beautiful, multicolored curtain of light. It ripples and folds like silk. Hidden behind it are hundreds of space objects, invisible to our eyes in the optical range, shy and secluded. But the infrared cameras of today's telescopes allow us to see through the veil of interstellar matter, revealing the secrets within. By combining data from different sources, astronomers have discovered a hidden population, about 700 protostars at different stages of evolution resting within this region. Their concentration is noticeably lower than in the crowded central part of the nebula. Here, things are calmer, due to the lower degree of gravitational compression of the interstellar gas. The absolute majority of these objects are very young by space standards. They are still sleeping, still gathering themselves, still in the process of formation. According to our modern understanding of stellar evolution, new stars form during a slow, gradual gravitational compression of large clouds of interstellar gas. It is a patient gathering of dust. Typically, as a result of this process, a giant nebula will split up into a number of closely grouped gravity centers, which soon turn into protostars. Such clusters are affectionately called stellar nurseries, or more scientifically, regions of star formation. At a certain point in this long gestation, the internal pressure of the compressed gas begins to push back, compensating for the gravitational forces. This brings the protostar to a state of temporary equilibrium, a moment of balance. The remaining material swirls around it into a giant vortex disk. Some of this dust is gently absorbed by the future star, feeding its growth, while the rest of it, by contrast, is expelled far beyond the boundaries of the nascent system. The growing magnetic field of the young star also plays its part in this cosmic ballet. Ionized particles accelerate through its field lines, spinning faster and faster, and then rapidly escape from the vicinity of the object. It has been calculated that such flows can reach speeds of up to several hundred kilometers per second. As these high-speed jets collide with the quiet gas clouds surrounding them, They create large-scale vortices and glowing hemispheres. These beautiful shock waves are called hurried objects. In the process, part of the energy of motion dissipates into light and heat, giving these bizarre structures different colors, painting the dark with strokes of neon. In addition, this ultra-fast motion affects the surrounding material, spreading shock waves across it, like ripples in a pond. Since stellar nurseries contain many closely spaced protostars, each producing several gas emissions, it is not surprising that hurried objects exhibit an amazing variety of shapes and colors. They are the result of a major cosmic collision, yet they appear like art. They are highly unstable and variable, flickering in the timeline of the universe. Hurried objects rapidly change color and shape, and typically disperse completely over several tens of thousands of years, a mere breath in the life of a galaxy. During this time, they cover between 1 and 3 light-years on an escape trajectory from their parent stars, fading as they go. About 400 such objects have been discovered so far, with their total number within the Milky Way estimated to be about 150,000. Perhaps one of the most awe-inspiring varieties of this natural phenomenon is known as the bullets. These are distinct structures, hundreds of astronomical units in diameter, also detected in the Orion Nebula, moving at incredible speeds. They act like piercing arrows, easily passing through the thinner hydrogen clouds and creating far-flung shock waves in their wake. According to spectral analysis reading the light, they emit the frontal parts of these objects contain atoms of iron that glow softly in the infrared. These bullets are estimated to be about 1,000 years old, and their origin is still a mystery to us. They supposedly originated from some catastrophic event, an ancient explosion that sent them flying through the silence. Moving on, zooming out until the individual stars become points of light, we will soon find that the Orion Nebula is but a small part of a much larger cosmic structure called the Orion Cloud. It is immense. It stretches for hundreds of light years, accounting for virtually the entire constellation of Orion in the Earth's night sky. This vast complex is home to other wonders. This is where the well-known Horsehead Nebula is located. It is remarkable for its bizarre shape, looking exactly like the silhouette of a night chess piece rising from a sea of light. It is a dense dust cloud about 3.5 light-years in diameter, clearly visible against the background with a contrasting, deep scarlet glow. Also close to the Orion Nebula, wrapping around it like a celestial ribbon, there is an impressive cosmic structure called Barnard's Loop. This emission nebula is colossal, about 300 light-years in size. It came into being about 3 million years ago, born from the echoes of the past created after a series of consecutive explosions of mutually close supernovae. After the shock-compressed gas jets mixed together, they produced a gigantic, curved nebula. The glow of several young stars gathered in an open cluster lights it from within, making it reddish in hue, like a faint ember in the sky. For all its beauty, the Orion Nebula is a fragile and unstable object by the universe's standards. It is a temporary masterpiece. The stellar winds and the pressure of light from so many young, energetic stars, as well as the gas emissions and turbulent vortices, are constantly dispersing its material into the surrounding space. The nebula is slowly evaporating. It has already lost about 60% of its original material, blowing it away into the void. In about 100,000 years, a short chapter in this story, it will be stripped of its remnants. In place of the shiny, multicolored cloud, there will remain an open star cluster, similar to the Pleiades, the 7 sisters that we see in our own winter sky. For a time, the young stars forming it will move together, a family of light traveling through the dark. But eventually, the gravity that binds them will loosen, and each will find its separate way through the vast expanse of the boundless galaxy around. As the stars of the Orion Nebula slowly drift apart to find their own paths in the galaxy, we turn our gaze toward a different kind of mystery. In the vast, illuminated ballroom of the universe, where billions of stars shine like lanterns, there are also those who cloak themselves in absolute shadow. It goes without saying that to detect a celestial object that absorbs all light shed upon it, a keeper of secrets that refuses to reflect even a single photon, is a challenging task, to say the least. They are the phantoms of the cosmos, hiding in plain sight against the black velvet of space. That is why, in our grand catalogue of the heavens, there are not that many confirmed black hole candidates today. We have found only a handful of whispers in the dark. Still, the quiet mathematics of the universe tells us a different story. Mathematical modeling suggests that their number in our galaxy alone may reach 100 million. To our minds, this may seem like an incredibly big number, a vast army of shadows. But let us place this in perspective within the grand scale of the Milky Way. Since there are between 200 and 400 billion shining stars lighting up our galactic home, it makes us realize that in all these endless expanses, black holes are actually rare. They are like rare, dark pearls scattered across a boundless, glittering ocean. Objects one doesn't come across that much, hidden deep within the fold of the night. In the quiet moments of our previous journeys, we touched upon the destiny of stars. We mentioned that not every star earns this mysterious afterlife. To become the progenitor of a black hole, a star must carry a heavy burden. It has to have a mass of at least 18 to 20 times that of our own Sunday. It is a destiny reserved only for the Titans. Only this immense weight will ensure that, at the end of its life, the star collapses with enough force, it creates a powerful enough supernova, a final brilliant shout into the void, to compress the scorching hot core of the star into an exceptionally dense clump of material. When this transformation is complete, gravity claims its ultimate victory. After this has occurred, nothing, not even the fleet-footed particles of light, will be able to stand up to the object's gravity force and escape. Everything is held close, locked forever beyond the boundaries of a conventional sphere, a silent border predefined by the so-called Schwarzschild radius. What used to be a shining star, full of fire and fury, transforms into a bizarre object. It becomes a point of singularity with an inner makeup that would defy description by the physical laws we are familiar with. It is a place where time and space fold into a deep, eternal sleep. One of these silent neighbors is closer than you might imagine. The object referred to by the catalog name A62000, or sometimes V616, is one of the black holes closest to our Earth that we know of. It rests quietly, about 3,300 light-years away from our planet, nestled in the constellation Monoceros, the unicorn. But it is not alone. It forms part of a binary star system, a delicate cosmic dance between the seen and the unseen. The visible partner in this system is an orange dwarf star, a modest sun with a mass half that of our own. It is a faithful companion. Every 7.75 hours, a short day, by any standard it completes a full orbit around an invisible object of unknown nature. It circles a ghost. Estimates show the mass of this invisible partner to be around 6.6 times that of the Sunday. For a neutron star, this would be too heavy, a weight it could not sustain. This simple fact leads one to believe, with a quiet certainty, that the bizarre, invisible object is more likely than not a black hole. It is a relationship of giving and taking. In addition to getting deformed and elongated into the shape of a teardrop by the more massive neighbor's gravity, the orange dwarf is also slowly sharing its essence. It is getting stripped of the outer layers of stellar matter. Imagine a stream of glowing mist, spiraling streams of scorching gas that gradually flow from the star to the black hole. This material does not fall straight in, but swirls around, forming a bright accretion disk. It is a halo of light surrounding the darkness. It is thanks to this dazzling disk, this radiant footprint, that the black hole was detected at all. This system is not isolated in the void. There are at least several dozen other stars in the environs of V616, silent witnesses to this dance. Some of them almost certainly have their own planetary systems, worlds that circle their suns in peace. However, the galaxy is always in motion. It is highly likely that in the distant future, as the eons pass, one of these stars will wander too close. It will get dangerously close to the black hole, caught in the web of gravity, and as a result, will be sucked in by the object's insane, unyielding pull. This unfortunate star will have no choice. It will begin a new journey, and in this case, the same slow demise is eventually awaiting the black hole's new companion as that of its current one, a slow unspooling of light into the dark. The way a black hole interacts with the universe around it is a story of balance. The process largely depends on their mass ratio. The smaller the distance between them, and the more massive the black hole, the stronger the influence of its tidal forces over its companion. It is a gentle but firm stretching. The star may be deformed by them, pulled like taffy, and get stretched towards the system's common mass center. Over time, they can also form channels, bridges of light, that would carry stellar matter closer to the black hole, adding drop by drop to the shimmering accretion disk. If the tidal forces happen to be strong enough, the embrace becomes too tight. They may well destroy the object that is being sucked in, not with a bang, but by turning it into a fiery ring, a necklace of gas that circles the drain of eternity. But amidst this power, there is also the possibility of stillness. It is assumed that there may be planets orbiting a black hole, just as if it were a regular star. It is a strange thought, a world where the sun is a black void ringed with fire. In contrast to a widespread opinion that paints black holes as cosmic vacuum cleaners, they are actually not able to suck in all objects around them indiscriminately. They are patient. From the point of view of gravitation, in astronomical terms, they behave just like any star with the same mass. If our sun were replaced by a black hole of the same weight tonight, Earth would not fall in. It would simply continue to orbit in the dark. That is why, incredibly though it may seem, a black hole may well have a stable planetary system. How could such a world come to be? There are several ways for them to form in the shadows. Firstly, nature is resilient. New celestial objects may originate in a nebula of gas and dust that is formed after the supernova explosion. From the ashes of the old star, new life begins. Influenced by gravitation, the dust motes begin to dance. They first form clumps of material that collide with each other and attract cosmic dust. As a result, over millions of years, they eventually turn into planets and satellites, as well as large numbers of small celestial objects, like asteroids and comets. But where would they get their warmth? The radiation of the black hole's accretion disk, that glowing ring of stolen matter, may be powerful enough to warm them. It could act as a dim, permanent sunset, warm enough to even melt ice on their surfaces. Hypothetically, a planetary system like that could be favorable enough for life to originate, and with any luck, to evolve in the twilight. Secondly, there are the adopted worlds. When a black hole captures and destroys another planetary system, chaos briefly ensues, but order can return. Some of its objects may choose to take up stable orbital positions around their new host. Of course, this makeover would bring about dramatic changes on the celestial objects' surfaces. Imagine a frozen giant, an ice planet far from its original sun, suddenly brought close to the heat of the accretion disk. It may transform into an ocean planet, a world of endless water under a dark sky, or perhaps a gas giant, stripped of its outer layers by the heat, may lose almost all of its hydrogen and turn into a Chthonian planet, the exposed rocky core of a giant, naked and new. Thirdly, the universe is full of wanderers. Space wanderers like rogue planets, worlds that have been kicked out of their home systems, or interstellar asteroids drifting through the void may also be ensnared by the massive object's gravity. They find a new home in the dark. Even though systems like that have not yet been discovered in practice, the universe is vast enough that there is no reason to suppose they are non-existent. Somewhere, in the deep dark, a lonely planet may have found an anchor. However, there is a boundary to this safety. If, on the other hand, a planet drifts too close to the system center, and the black hole is massive enough, other factors come into play. It is the danger of the shoreline. A scorching hot stream of material, forming the accretion disk, acts like a cosmic wind. It will strip the celestial object of its atmosphere, peeling it away layer by layer. Its friction will slow the planet down, robbing it of its momentum, and pull it still closer to the black hole. Eventually, the gravity becomes a physical tide. Extremely powerful tidal forces will take hold. They will not crush the planet, but gently pull it apart, ripping the planet to tiny shreds, unweaving the very fabric of the world. The debris, now just a stream of dust and rock, will be pulled into the accretion disk. It will join the river of light and gradually melt in the hot gas around. In the end, after a long and spiraling journey, they will inevitably get swallowed up by the black hole, crossing the horizon to become a secret, and in essence, become part of it forever. In the quiet observation of the cosmos, it is posited that the family of black holes is not a single, uniform line, but rather a diverse collection of shadows. There are three main types of these enigmatic objects to be found in the universe, and they are different, first and foremost, in terms of their weight, their presence in the fabric of space. The first type, the monarchs of the dark, can be found resting in the very center of most spiral galaxies, including our own. These are the supermassive black holes, gargantuan entities, with masses reaching the equivalent of several billion solar masses combined. Imagine a weight so profound, it anchors the entire galaxy around it. The density of matter in the central part of a galaxy is generally extremely high. It is a crowded, bustling downtown of the cosmos. This is the reason why a big number of large and bright stars originate there, quite closely packed together like city lights. As these massive stars rapidly burn out, exhausting their fuel in a glorious rush, they transform into black holes. But the story does not end there. In such a crowded space, these black holes rapidly grow, feeding on the dust around them, and often merge with each other in a silent embrace. As a result of these unions, supermassive objects are born. They are often surrounded by giant accretion disks, made of scorching hot material, a swirling carousel of light. They illumine space so brightly, casting such a powerful glow that it makes them seen from billions of light years away. Even if the galaxy that hosts them is too faint to be seen, these beacons, known to us as quasars, shine through the dark, acting as lighthouses across the ocean of time. The second type is the middle child of this family. They are much more widespread, scattered like seeds across the sky. But at the same time, black holes like these are not that easily detectable. They are quieter, more elusive. Their masses are close to those of stars, ranging from just a few times to perhaps 100 times the mass of our Sunday. They form out of large stars at the end of the latter's life cycle, the final, dramatic act of a supernova. By devouring other celestial bodies that wander too close, and by sipping on streams of interstellar gas, these objects gradually gain in size. Eventually, they turn into intermediate mass black holes. And just like their larger cousins, they can also merge together. When they do, the collision is so profound that it generates gravity waves, ripples in the very pond of space-time, that distorts space for many light years around, a silent tremor passing through the universe. The third type is the most mysterious of all, the hypothetical primordial black holes. Their existence has been inferred not from observation, but from today's theory of the universe's origins and evolution. In the chaotic, hot, and dense moments immediately after the Big Bang, the universe was not smooth. There were fluctuations in the matter that filled space in its early stages of evolution. These tiny knots of density may have been favorable for black holes of infinitely small size to originate. It should be mentioned that, according to our estimates, these ancient relics behave differently. The smaller an object of this type, the faster it evaporates, leaking its energy back into the universe. At the end of its life cycle, it is believed to turn into a tremendously powerful electromagnetic impulse, a final flash of existence. Models show that primordial black holes with masses around 10 to the power of 12 kilograms are supposed to be flaring up sometime around now, in our current epoch. But to date, the sky has kept its secrets. No such event has been registered yet. Deeper still in the realm of theory, according to a certain hypothesis, a microscopic black hole might form from a collision of extra-high-energy elementary particles, a spark of darkness created in the blink of an eye. This variety is referred to as quantum black holes. Still, the conditions necessary for such an event to happen are extreme, impossible to be reproduced in laboratory conditions on Earth. Furthermore, the estimated life expectancy of these hypothetical objects is so small a fraction of a nanosecond that it can hardly be measured with today's latest and most advanced methods. That is why, for now, quantum black holes still officially exist only in the quiet pages of theory. Of course, it goes without saying that it is extremely difficult to detect such dark and compact objects against the black backdrop of space. It is like looking for a black cat in a dark room. However, they sometimes reveal themselves. Some of them happen to have a star companion, a partner in light. The anomalous trajectory of movement of the visible star gives telltale signs of there being an invisible thing in close proximity, pulling on it, leading it in a waltz. Another popular method of detection is the observation of accretion disks, those halos of fire we spoke of. These object spectra, the rainbow of light they emit, have some typical features that allow astronomers to tell them apart from other sources of light in space. Sometimes, we are lucky enough to get a snapshot of a disk with a black spot in the center, the shadow of the event horizon itself. That is evidence that the observed object's structure is quite unusual. A black hole may also be detected thanks to a phenomenon called the gravitational microlensing effect. This involves detecting the massive invisible object as it transits or passes between the Earth and a remote star. It acts like a lens. As it passes, Its gravity bends the light of the background star, changing the star's spectrum and brightness in a special, predictable way. But admittedly, this method requires a number of rare factors to successfully work. The alignment must be perfect. There is hardly any doubt that space is filled with great numbers of objects that are dark and not easily noticeable. Among the stars, there may be wandering black holes. These are the nomads. These mysterious objects, roaming around in interstellar space, untethered to any system, absorbing every bit of light they come across, will probably never reveal their secrets to us. They float silently, passing through the void like ghosts. As we turn our telescope from the dark to the light, our curiosity often seeks out places that feel like home. As a rule, it's the potentially habitable planets with favorable conditions and a moderate climate that especially catch one's attention among the great diversity of other worlds out there. We look for blue skies and liquid water, or else, on the contrary, extremely dangerous objects stand out among others, drawing us in with their ferocity. Still, there is yet a third category of worlds. It consists of anomalous celestial objects, manifesting unusual behavior which is barely scientifically accountable. Objects like that challenge our knowledge and deserve special attention. They are the puzzles of the planetary family. This is exactly the kind of world we will be looking at now. Let us travel back in time slightly, to the year 2009. We find ourselves in the environs of the Kepler 413 system. It is a quiet corner of the galaxy. Suddenly, an unknown object passes between our planet and a distant star, briefly reducing its luminosity. It casts a shadow. Astronomers take this event to be a standard exoplanet transit, a routine discovery, and announce the discovery of a new celestial body. High-precision calculations even make it possible to determine its parameters. The planet turns out to be a cool giant, with a mass of about 25 times that of the Earth, and a radius of about 40% that of Jupiter. It seems like a familiar story. However, the universe loves a surprise. 180 days later, when the planet was expected to cross the face of its star again, the transit never occurred. The stage was set, but the actor did not appear. The planet, so clearly visible in the old data, seemed to have vanished without a trace. It was as if it had dissolved. A dark spot in the photosphere of the star, or a giant dust cloud moving in its vicinity, would have accounted for the mysterious phenomenon. Perhaps it wasn't a planet at all? But these hypotheses were dispelled when, 800 days later, the mysterious object reappeared just as suddenly as it had vanished. It returned from the void. The hypothetical planet eclipsed the disk of its parent star 5 times in a row before disappearing again. It was playing a game of cosmic hide-and-seek. Still, the key to the riddle had been found. It turned out that the world known as Kepler 413b has a highly unusual orbit. The celestial body is located near a binary star, 2 suns circling each other, and sits about 36 astronomical units from the system's common mass center. Because of this dual sunrise, its trajectory is constantly affected by gravitational perturbations. The change in gravitation of the 2 nearby stars shifts the orbital plane considerably, causing cyclic oscillations. Imagine a spinning coin just before it falls. It wobbles. When the deviation reaches its maximum, the object leaves our line of vision from Earth, passing above or below the star, and then returns to it years later. Calculations show that Kepler 413b's orbit also precesses. It wobbles like a toy top, with a periodicity of about 11 years, deviating 2.5 degrees in each direction from its average value. But the strangeness does not end there. The planet's own axis of rotation also changes its position significantly, swinging with a maximum angle of inclination of up to 30 degrees. Combined with a notable eccentricity of the orbit and its periodic shift, the climatic conditions on the surface change in a bizarre, almost chaotic way. On Earth, we have seasons because of a steady tilt. Here, the region that receives the most light from the parent star is constantly shifting, moving wildly from the equator to the poles and back. This leads to dramatic variations in temperature, swinging from freezing to boiling in short spans. It is likely that this process generates huge, planetary-scale hurricanes, storms larger than worlds, which can be larger than the Great Red Spot of Jupiter. In this turbulent atmosphere, air currents can carry ice clouds at speeds of several kilometers per second, whistling through the sky before gradually becoming unstable and dispersing into the mist. Meanwhile, the collision and deformation of these massive vortices is capable of causing tremendous atmospheric emissions. These plumes of gas have the power to overcome the planet's gravity and reach outer space. According to calculations, they will hang a while up there, suspended in the silence, before gravitational forces pull them back down into the clouds. All these incredible phenomena make the planet a rather harsh place to visit, a world of constant flux. However, it may seem like a tranquil, serene island in comparison to the following world we shall visit. Let us cast our minds 190 light-years from Earth to the environs of the HD 80606 system. Here sits a yellow dwarf star, surprisingly similar in parameters to our own Sunday. It looks warm and familiar, but it is orbited by a planet with a highly variable climate, a world of extremes. This planet does not circle in a round path. Instead, it follows a lonely, elongated ellipse. It whizzes towards its parent star as rapidly as a giant comet, diving in from the cold dark. It screams towards the fire, burning itself in the hot rays of the star's corona, only to sling itself around and retreat to the frozen periphery of the system. The object is a gas giant, a heavy world with a mass 4 times that of Jupiter and a radius just slightly different from that of Jupiter. Let us linger for a moment in the silence of the outer reaches, where this wanderer, HD 80606b, spends the long winter of its year. At the furthest point in its lonely, elongated orbit, the planet floats a staggering 88 astronomical units away from its parent star. Here, the distance is so vast that the star appears as little more than a piercingly bright diamond in the black velvet sky, offering no more warmth than our own sun grants to the frozen lands of Earth. It is a time of stillness. In this cold twilight, it has been suggested that the atmosphere settles into a deceptive calm. Clouds begin to form, not the fluffy white cotton we know, but shimmering veils consisting of water vapor droplets, sharp ice crystals, or even microscopic particles of quartz suspended in the haze. If there were satellites orbiting this gas giant, standing on their surface would feel strangely familiar. The temperatures could be comparable to a brisk day on Earth, habitable and quiet. But this world is a traveler that cannot rest. As the planet begins its long fall back towards the star, the conditions on it change with a terrifying speed. It is a dive into the furnace. Within a mere 55 days, a heartbeat in cosmic time, the distance between the planet and the star shrinks by a factor of nearly 30. Imagine the sun in the sky, growing larger and larger with every passing hour, transforming from a distant point of light into a monstrous, roaring fire that fills the entire horizon. The energy flux, the raw heat pouring down from the star, increases by a factor of 800. Observations show us a scene of dramatic transformation at the lowest point of its orbit. As it skims the surface of the star, The exoplanet's temperature roughly doubles within a matter of just 6 hours. It surges from a scorching 500 degrees to a hellish 1,200 degrees Celsius. This is not a gradual sunrise. It is a flash heating, a sudden explosion of thermal energy that the atmosphere simply cannot handle. Such drastic changes result in violent hurricanes of unimaginable power. The heat acts as an engine, driving winds that whip around the planet at speeds of up to 5 kilometers per second, faster than sound, faster than any bullet. By absorbing an incredible amount of heat in such a short time, the atmosphere of the gas giant expands violently. It heaves and swells so fast that it produces shock waves, titanic walls of pressure capable of sweeping across the entire planet multiple times, ringing the world like a struck bell. In this cauldron, chemistry itself begins to break down. The water vapor that once formed peaceful clouds is torn apart, broken down into raw oxygen and hydrogen by the sheer ferocity of the temperature. And the quartz clouds? The crystals evaporate without a trace, turning into rock vapor. But as the winds carry this vapor to the cooler night side, it recondenses, falling from the sky not as rain, but as gigantic, swirling sand clouds. It is a world where it rains molten glass and hot dust. In all likelihood, HD 80606b is a solitary traveler. It is the only planet in its system, a lonely king of a ruined castle. The gravity of another nearby star, circling in the distance, has not only warped its orbit into this extreme shape, but has also wreaked havoc on the protoplanetary disk long ago. It swept the room clear, so the chances of encountering other large objects nearby are rather slim. It dances alone in the dark. However, the universe is vast, and loneliness is not the only story it tells. Destabilization of a planetary system due to the interaction of celestial bodies is not uncommon. Sometimes, worlds are crowded together in a dangerous embrace. Let us drift 1,530 light-years away from Earth to a place where the dance is far more intimate. The environs of the Kepler 3-6 system. The central object here, the hearth around which the planets gather, is a yellow subgiant. It is an elder star, its mass comparable to that of the Sun, but it has puffed up with age, its radius swelling to be 62% larger than that of our own star. It casts a warm, golden glow over its family. There are 2 planets rapidly orbiting this star, locked in a rhythm that is both beautiful and terrifying. One is a rocky, super-Earth, a heavy world of stone and metal. The other is a hot, mini-Neptune, a gaseous cousin. They are neighbors, in the truest sense. Every 97 days, their different speeds bring them together in a cosmic conjunction. They mutually approach at a critical distance of only 1.9 million kilometers. To us, that sounds far, but in the vastness of space, it is a whisper. It is about 20 times less than the minimum distance between the Earth and Venus. Imagine standing on the surface of the rocky planet during this moment. You would look up and see the other planet, the mini-Neptune, looming in the sky, a gigantic, swirling orb of gas, huge and imposing, filling your vision. At such moments, their mutual attraction causes global cataclysms. They pull at each other with invisible hands. But the encounter is brief. After a few days, the celestial bodies diverge again, drifting apart until the next resonance calls them back. According to calculations, the gravitational interaction between the planets at the point of closest approach is fierce, about 13 times higher than the gentle tug between the Earth and the Moon. But while the Moon only raises our tides, these planets raise the ground itself. In particular, this effect should be seen on the surface of the rocky planet. Under the influence of these titanic forces, the planet is squeezed and stretched. Its crust, solid rock, may crack and shift, groaning under the strain. This causes earthquakes, or perhaps Kepler quakes, of incredible power, tremors that would shatter mountains. The resulting chasms that open up may be hundreds of kilometers long, glowing scars on the planet's face. This constant kneading of the interior causes multiple eruptions of gigantic volcanoes. It is likely that some regions of the planet do not cool down in the short period of relative tranquility between approaches. Instead, they form seas of eternally bubbling red-hot magma, glowing fiercely in the night, a testament to the gravitational friction that never truly sleeps. The reasons for the formation of such an unusual, tightly packed system are still debatable. It is a puzzle astronomers are still piecing together. What we do know provides us with a picture of a world stripped bare. The super-Earth, dubbed Kepler 3.6b, orbits remarkably close, just 0.12 astronomical units away from its parent star. It rushes through its year, taking only 14 days to complete a full orbit. It is a heavy world. The super-Earth's mass is 3.8 times that of the Earth, and its radius is 1.5 times that of our planet. It is a dense, compact ball of matter. The object has been calculated to have a scorching surface temperature of 980 Kelvin, or just over 700 degrees Celsius. But it is the density that tells the saddest story. With an average density about 30% higher than that of Earth, the data suggests that this celestial body could be a Chthonian planet. This is a poetic name for the core of a gas giant that has lost its atmosphere. Imagine a majestic planet, like Jupiter, venturing too close to the fire. Over eons, the gentle gases are stripped away, leaving only the hard, metallic heart exposed to the void. Such objects contain many heavy metals, like iron and lead, as well as sulfur and silicon compounds. It is a naked core floating in space. It is likely that the light elements hydrogen and helium that once made up the thick, dense shell of the celestial body may have been blown into space by the relentless stellar wind of the subgiant star. Nor should we forget the second planet's gravitational pull. The neighbor, in its regular flybys, could potentially have contributed to this process, slowly stealing the atmosphere of its smaller companion, layer by layer. That neighbor, the object called Kepler 3.6c, is likely to fall into the class of hot mini-Neptunes. It keeps a slightly safer distance, moving in a nearly circular orbit with a radius of 0.13 astronomical units, completing its journey every 16 days. It is the heavier of the two siblings, with a mass 7 times that of our planet, and it is physically larger, with a radius 3.7 times that of the Earth. Because of its proximity to the star, the temperature of this object is also very high, 928 Kelvin, or 655 degrees Celsius. But unlike its stripped neighbor, this celestial body retains its blanket. It should be surrounded by a thick, multi-layered atmosphere consisting mainly of nitrogen, hydrogen, and helium. If you were to descend into this atmosphere, you would find no distinct surface. Deeper down, the pressure inside the gas shell increases immensely. The gas gradually thickens, becoming heavier and denser, until it turns into an ocean of supercritical fluid, a strange state of matter that is neither liquid nor gas, but something in between, swirling around the solid core, hidden deep within. In this chaotic dance, meanwhile, under certain conditions, truly fantastic phenomena are also possible. The gravity of the more massive planet can potentially capture satellites from its smaller companion. Imagine a moon being torn from its sky, pulled across the void to circle a new master. Or the tidal forces may be too strong, and instead of capturing the moon, they may destroy it, grinding it into dust to form vast asteroid streams that trail behind the planets like a glittering veil. In addition, the mutual gravitational pull of the two planets constantly distorts their orbits. They nudge and jostle each other, altering eccentricity and other parameters, making their paths wobble. Because of this, the entire system behaves chaotically and unpredictably. It is a clockwork mechanism where the gears are slipping. Its evolution cannot be predicted over any extended period. The mathematics becomes a fog of possibilities. Modeling shows a grim future. There is a 91% probability that the dance will end in disaster. The calculations suggest that the two planets will collide with each other over the next 70 million years. It will not be a quick end, but a slow, spiraling convergence. When they meet, it will produce hundreds of thousands of pieces of debris-shattered rock and splashed magma which will disperse throughout the planetary system. They will create a still greater chaos within it, a cloud of shrapnel orbiting the star. Such tremendous cataclysms may have occurred more than once in the history of the galaxy, grinding worlds into dust to build new ones. Leaving this chaotic pair behind, we travel further, seeking something grander. About 434 light-years from Earth, we find a young, sun-like star. Orbiting this star, located 4 astronomical units away, a distance similar to Jupiter's distance from our Sun, is a surprising object. It has been intricately dubbed Super Saturn. But this is no mere planet. It sits on the blurry line that divides the planets from the stars. It is a brown dwarf, or perhaps a large gas giant, with a mass 20 times as heavy as Jupiter. It is a titan of the dark, immense, and heavy, reigning over its domain with a gravitational grip that dwarfs anything we have seen so far. As we draw closer to this colossal object, known in the quiet catalogues of astronomy as J1407b, or more affectionately as Super Saturn, we begin to realize that we are looking at a snapshot of the ancient past. Observations show it to be a remarkably young planet, a mere infant in the lifetime of the universe, only about 15 to 16 million years old. It is still in the throes of creation, still forming, still gathering itself from the chaos. Its atmosphere is a thick, primordial soup, consisting mostly of hydrogen and helium, swirling in deep, banded storms that would dwarf entire continents on Earth. Deep within these gaseous layers, hidden from view, lies a massive metallic core, beating like a heavy heart in the depths. But it is not the planet itself that steals the breath away. It is what surrounds it. This object is spun by a system of rings, like Saturn's, but on a scale that defies belief. If Saturn is a gem, this is the crown jewels of the entire galaxy. The transit method, watching the light of the parent star flicker and fade as the planet passes in front, has revealed a complex tapestry of at least 37 distinct rings. They are not merely lines. They are broad highways of dust and ice. The largest one, the outer rim of this majestic disk, has a radius measuring about 0.6 astronomical units. To put that into a perspective that our minds can hold, that is comparable to the entire distance from the Sun to the orbit of Venus. It is a disk so vast, it spans about 640 times the radius of Saturn's rings. These are not gossamer threads. They are heavy with matter. According to calculations, the total mass of this circumplanetary disk, this swirling halo, is bigger than the mass of the entire Earth. It is a world's worth of rock and ice, ground into dust and spread out into a sheet. And unlike the calm, orderly rings of Saturn, the behavior of this system manifests signs of randomness and youthful energy. Mathematical modeling shows that such gargantuan structures are not stable features etched in stone. They are transient, shifting, and gradually disintegrating over the eons. Imagine a slow-motion waterfall of stone. Some of the objects making them up, the rocks, the ice boulders, lose their velocity, succumbing to the drag, and fall inward to the central planet, becoming shooting stars in its thick atmosphere, while others, on the contrary, catch a gravitational wave, accelerate, and leave the disk forever, flung out into the darkness to become lonely wanderers. However, do not fear for the disappearance of this beauty. This process is greatly extended in time. It is a decay so slow, it looks like stillness, a majestic unraveling that may take several 100 million years to complete. As we scan this vast expanse of rings, we notice something fascinating. A silence in the noise, a large rupture, a clean gap with a radius of about 0.4 astronomical units was detected in the system of rings. In nature, emptiness often tells a story of presence. This gap is considered indirect, yet compelling evidence of the existence of an exosatellite, a moon orbiting in this region. This hidden moon is substantial, estimated to be about 80% the mass of the Earth. According to our current understanding of the physics of space objects, this is a shepherd moon. It is a kind of object capable of clearing its orbit, using its gravity to sweep up the small debris in its path, carving a wide rupture in the ring structure like a finger drawn through sand. In addition, subtle ripples in the rings suggest the presence of at least two more celestial bodies, smaller siblings with a mass of each about 30% that of the Earth, located further out at a distance of about 0.25 astronomical units from the center of the brown dwarf. Just like it is the case with the large planets known to us in our own solar system, it can be assumed that this is a bustling family, a total of several hundred exosatellites, including rather massive ones, may be located within the gravitational influence of the central object, dancing through the gaps in the rings. Let us now allow our minds to drift down, to land on the surface of one of these hypothetical moons. A simulation of such a system taking into account the radiation from the distant parent star, the immense heat flow radiating from the giant planet itself, and the warming friction of tidal influences shows that the temperature of these celestial bodies could approach comfortable values. It might be warm enough for liquid water, warm enough, perhaps, for life. One can only imagine how enchanting, how truly otherworldly the night sky would be from the surface of such an exosatellite. You would not see a black void sprinkled with stars. Instead, at this distance, the brown dwarf, the super Saturn, would dominate everything. It occupies 70 times as much space in the sky as the full moon does on Earth. It would hang there, immense and brooding, glowing with a dull, reddish heat. Its soft, amber glow can dispel the darkness completely, turning the night into a misty, eternal twilight, where shadows are long and soft. And the rings, instead of the star-spangled canopy we know, the planet's sky is crisscrossed by vast swathes of light from horizon to horizon. They would look like arches of diamond dust, catching the light of the distant sun and the glow of the planet, casting intricate bands of shadow across the landscape. But beauty often comes with a price. At the same time, The tidal forces of such a nearby massive body would be relentless. They could provoke multiple eruptions on the satellite's surface, keeping the geology alive and violent. If there is water, its hypothetical ocean could slam the land with giant waves, tides that do not measure in meters, but in miles. The width of a tidal zone, the area between high and low tide under such conditions, could reach hundreds of kilometers. It would create a unique climatic zone, a shifting landscape that is something like a cross between dry land and the ocean floor, forever changing with the breathing of the tides. Still, it should be mentioned that such structures, for all their grandeur, tend to be unstable. They change their appearance quite quickly by cosmic standards. Beyond recognition, the rings will fade, the gaps will close or widen. It is difficult to say how much longer the universe will be able to admire these giant rings and what they will look like in millions of years. They are a fleeting masterpiece, painted on the canvas of gravity. Leaving the magnificent chaos of the super Saturn behind, we turn our ship towards the deeper, darker waters of the galaxy. Assumptions about the existence of space objects the size of a planet which are independent from any star have been around for a long time. These are the ghosts of the galaxy. Such celestial objects, freely drifting around into interstellar space without a sun to warn them, are referred to by many names: orphan planets, free-floating planets, or, most commonly, rogue planets. Astronomical bodies of this kind are the masters of stealth. They emit very little thermal energy and virtually no light energy into the space around them. They are cold, dark, and silent. It is suggested that there are no bodies in their close proximity. They have no suns, no moons, nothing they could clearly interact with or be bound to. They float in absolute solitude. That is why it is hardly surprising that these objects are so difficult to detect. We cannot see them with our eyes. We can only sense their presence by the way they bend the light of stars behind them. The first potential representatives of this class of planets were spotted as recently as in the early 21st century. It is a new frontier. The warmest rogue planets, those that still hold the heat of their formation, can be detected with sensitive infrared telescopes, glowing faintly like dying embers in the dark. Others reveal themselves thanks to something called the gravitational microlensing effect. This happens when a rogue planet drifts precisely in front of a distant star. For a brief moment, the planet's gravity acts like a lens, magnifying the starlight. It is a cosmic wink, a fleeting signal that says, "I am here." As one would expect, this class of celestial objects is one of the most mysterious and understudied today. It is hard to study what you cannot see. Only 3 astronomical bodies can be classified as rogue planets with a sufficient degree of certainty, with the overall number of rogue planet candidates hovering over 24. However, do not let these small numbers fool you. Incidentally, according to the analysis of data collected in the course of the OGLE project, a massive survey of the sky, the Milky Way may supposedly be home to up to a staggering 100 billion objects of this class. Think of that. For every star you see shining, there might be a lonely planet drifting in the dark between them. This may only mean that right now, we are at the very beginning of an upcoming series of discoveries in this field. The dark is full of worlds. Our notions of what rogue planets are like have long been based purely on assumptions and hypotheses, sketches drawn in the mind, but with the technological advancement of highly sensitive observation equipment, there arose opportunities to put them to the test in practice. We can finally look into the shadows. The rogue planet, lying closest to the Earth, among those already confirmed, carries the designation WISE 0855 to 0714. It is a neighbor, relatively speaking, located just 7.27 light-years away from the Sunday. It was detected in 2014 with the WISE Orbital Infrared Telescope, a hunter of heat. The astronomical body cannot be seen through optical telescopes to our eyes. It is invisible as it emits no visible light to speak of. It is a phantom. The reason for this invisibility is its extremely low temperature. It is a frozen world, with temperatures ranging from 225 to 260 Kelvin, or, in terms more familiar to us, about 48 to 13 degrees Celsius below zero. It is a deep, preserving cold. In terms of its parameters, it resembles a cooled-off gas giant, a Jupiter that has been left out in the snow. Its age cannot be under 1 billion years. It has been wandering for a very long time. The rogue planet is mostly made up of hydrogen, the simplest element. However, in 2016, the Gemini Observatory produced fascinating evidence of the presence of large amounts of water in its atmosphere. But this is not water as we know it. It is not liquid oceans or flowing rivers. In the deep cold of interstellar space, it is suggested that water is condensed into clouds made up of the tiniest particles of ice. Imagine a world wrapped in clouds of diamond dust, swirling in the eternal night. Today, it hasn't been established for certain how this object or any of its kind came to be. Why is it alone? There are currently 2 versions suggested by researchers, 2 stories of origin. According to the first story, a celestial object like that starts its life cycle in the warmth of a family in the protoplanetary disk of a regular planetary system. It was born around a star. However, gravity is a chaotic game. Mathematical modeling of this process shows that if the original cloud of gas and dust is heavy enough, and if giant planets form too close to one another, a gravitational war begins. It is highly likely that at least one planet will be ejected beyond the system. It is a violent departure. The planet is flung out by the gravity of its siblings, exiled into the cold. The celestial object may also be forced out of its star's environs if another massive star passes it by, disrupting the orbits, or else if its planetary system collides with another system. The chances of events like that, a cosmic collision, are admittedly comparatively small, but in the vastness of time, the unlikely becomes the inevitable. The other version tells a different, lonelier story. It has it that the space object was born just like any other star, in the solitude of the void. It formed on the compression of interstellar gas, collapsing under its own weight. It tried to become a sun. At the same time, the mass of the object proved to be too small. It did not gather enough material to ignite, to unleash any thermonuclear reactions in its interior. It failed to shine. It goes without saying that in this manner, it may turn out only as a gas giant or a brown dwarf, a failed star, but not a rocky planet similar to the Earth. This leads to a debate among the stargazers. Some researchers don't agree that these objects should be seen as planets at all, arguing that planets must orbit stars. They classify them as sub-brown dwarfs instead. Others suggest using the beautiful term planetar for all interstellar wanderers that don't show any thermonuclear activity, regardless of how they were born. Bearing in mind today's notions of the makeup of brown dwarfs and gas giants, we may estimate the mass of our neighbor, WISE 0855, at anything from 3 to 10 Jupiter masses. It is heavy, dense, and thick. This mass rather falls short of the crushing weight needed to start a thermonuclear reaction, so it will never light up as a star. But it is massive enough to hold on to the warmth of its creation. It is quite enough to keep the heat effectively trapped inside the planet, glowing softly in the infrared, a lonely ember drifting through the endless night. Taking into account our knowledge about the natural laws, those silent rules that govern the dance of atoms and stars alike, we can close our eyes and predict what the conditions on such a lonely astronomical body's surface might be. Like, it is a journey of imagination, guided by the lantern of science. For example, consider the research by David John Stevenson from the University of California. His work suggests a comforting thought, that gas giants, similar to our own majestic Jupiter, do not simply freeze into blocks of ice the moment they are cast out from their family. They do not cool off instantly after receding from the warmth of their star. Instead, they are built to endure. Their thick, swirling atmosphere of hydrogen acts like a heavy, reliable quilt, providing exceptional thermal isolation. It wraps the planet in layers of gas, trapping the heat deep inside. And deep within that embrace, the planet holds a secret, a dense and hot nucleus made up of metallic hydrogen, glows with the heat of its formation. It acts like an internal furnace, keeping the planet heated from the inside out for a considerable time, billions of years, perhaps. It is a world that carries its own fire through the cold night. Estimates show that within this thick atmosphere, there are hidden layers where the chill of space cannot reach. The temperature of the lowest strata of a hypothetical celestial object's atmosphere may be high enough for liquid water to be around. It wouldn't be oceans as we know them, but rather, water is likely to be present in the atmosphere as giant clouds made up of the tiniest droplets. Imagine floating in a never-ending mist, a thick fog of water vapor suspended in the dark, warm and enveloping. These deductions are not mere daydreams. They agree with the results of rigorous mathematical modeling of the object WISE 0855 carried out by a team of scientists from the University of Edinburgh. Their numbers painted a picture of a world that is cold, but not dead. The model showed that the most likely temperature value of the planet's surface, or rather, the top of its cloud deck, is about 250 Kelvin. That is roughly 23 degrees Celsius below zero. It is a crisp chill, similar to a winter evening on Earth, but far from the absolute zero of the void. But as we descend deeper into the model, we find something even more hopeful. The celestial body's atmosphere also appears to have a comparatively warm layer, a band of comfort about 100 kilometers thick. In this zone, the pressure creates a density that fluctuates from 0.4 to 1.2 milligrams per cubic centimeter. To a biologist, those numbers are exciting because they are comparable with the conditions in our own atmosphere on Earth. And so, it is thought whispered, really, among hopeful researchers that this environment should be favorable for potential organic life. It is a cradle hidden in the dark where microscopic life might float on the winds, safe within the gas giant's embrace. Incidentally, a planet doesn't have to be a massive gas giant to avoid freezing in the cosmos. Even the smaller, rockier worlds have their ways of surviving the loneliness. In the year 2020, the gaze of our telescopes fell upon a new mystery. A rogue planet candidate was detected using gravitational microlensing techniques, watching the light of a distant star bend around an invisible traveler. It was given a long, complex designation, a string of numbers that serves as its only name for now. It is still awaiting confirmation of its official rogue planet status, and its parameters have been defined only generally so far, painted in broad strokes according to preliminary data. However, what we do know is intriguing. The object is comparable to the Earth in terms of its mass. It is a sister to our home, drifting somewhere between 3,000 and 18,000 light-years away, in the deep fields of the galaxy. According to our current scientific notions, an object with a modest mass like that is not supposed to be a gas giant. It does not have the gravity to hold onto such a thick atmosphere. It is more likely to be a rocky planet, a world of stone and ice. This, in its turn, offers good grounds to believe that the object has a tragic history. It likely formed in the warm, crowded protoplanetary disk of a planetary system, surrounded by siblings. As the latter was forming, in the chaotic billiards game of the early solar system, it may have been ejected from the system as a result of a cataclysm in space, or alternatively, perhaps it fell under the influence of a larger neighbor, a gas giant that flung it outward with a gravitational slingshot. After that, it was left to its own devices, cast out into the eternal night, and so became a free-floating planet. What will happen to it next? Its destiny is predefined by a combination of several factors, a delicate balance of physics. Provided the object's atmosphere is sufficiently dense, it will be reliably thermally isolated. The air itself becomes a blanket. But even if the air freezes, there is hope. Potentially, a thick layer of ice on its surface could produce the same isolating effect. Think of a frozen lake in winter. The ice on top is cold, but it protects the water below. In addition, with the object's interior still scorching hot from its birth, and with radioactive elements like uranium and thorium undergoing slow decay deep in the core, the planet generates its own heat. Because of this internal warmth trapped by the ice shell, most of the hypothetical ocean, a dark, global sea covering the entire world, will remain in a liquid state. It is a pitch-black ocean, hidden beneath miles of ice, warm and rich with minerals. And if the planet happened to have a moon, a faithful companion that it dragged along during its ejection, the story becomes even more dynamic. If this is the case, tidal forces are likely to continue to deform and knead the planet. As the moon circles, its gravity pulls on the planet, warming up the lithosphere through friction. Theoretically, with any luck, primitive anaerobic life forms, life that needs no sun, no oxygen, may have stayed around in these deep waters, huddled around volcanic vents, although, of course, it would be next to impossible for us to discover their traces now, hidden as they are under miles of ice and light years of distance. Most of the data about the rogue planets we know today were arrived at following patient mathematical modeling and complex calculations. We build these worlds in our computers before we find them in the sky. It was possible to do these calculations thanks to the tiny bits of information gleaned with the help of orbital and Earth-based telescopes, collecting photons like raindrops in a bucket. Even as I speak, in the quiet labs and observatories around the world, a project is being worked on. It has been known by names like Cleopatra or related microlensing initiatives. Its main objective, noble and difficult, will be to search for these free-floating planets and other objects in space with a subsequent, precise definition of their parameters. The project relies on the phenomenon we touched upon earlier, microlensing. It is a subtle art. It is a phenomenon that occurs when a celestial body, dark and invisible, passes between a remote star and the observer on the Earth. For a brief moment, the gravity of the planet acts as a lens. It interferes with the light emitted by the remote star in the background, making it brighten momentarily. But to truly measure these ghosts, we need perspective. When observed from different angles, say, one telescope on Earth and another floating far away in space, the moment of transition will be registered a fraction of a second sooner in one observatory than in another. This tiny difference is referred to as lensing parallax. This effect allows scientists to triangulate, to gauge the distance to a detected object, as well as its mass and dimensions, with incredible accuracy. To achieve this, an interplanetary spacecraft is planned to be created within the project. It is a traveler built by human hands, supposed to blast off the surface of the Earth, perhaps in the window of the 2020 seconds, launching alongside a mission to Mars or venturing out alone. After leaving our blue world, it will enter its own lonely orbit around the Sun, sitting in the silence, watching the stars. The project will be aided by a specialized artificial intelligence component. This mind, made of silicon and code, will have a crucial mission: to process and analyze the collected information. It will sift through the noise of the universe, looking for the telltale blip of a rogue planet, working tirelessly while we sleep. The Cartra and Cleopatra initiatives and their successors will certainly delight us with a wealth of exciting and important information. They will shine a light into the shadows, so there is a lot to look forward to in our quest to understand the dark. But ultimately, we must ask, what is to become of all those rogue worlds out there? What is the final chapter for these planets, drifting quite by themselves in the dark depths of the universe? In theory, there is a chance for redemption. An orphan planet may be captured by the gravitational field of a passing star and become part of its planetary system, finding a new family and a new sun to warm it. But this chance is, by all accounts, minuscule. The universe is too vast, and the paths are too lonely. Most objects like that are destined to a more solitary fate. They are destined to wander for billions of years through endless expanses of space. They will drift through the silence, while slowly and inevitably cooling off. The internal fires will dim, the oceans will freeze, and the atmosphere will settle as snow. Eventually, in the deep, deep future, they are to be swallowed up by black holes, returning to the singularity, or else destroyed as a result of a cataclysm in space, shattering into dust. They will vanish, never to reveal their secrets to mankind, keeping their stories locked in the ice forever. As we let our minds drift away from these lonely planets, we pull back, we zoom out, further and further, until the rogue planets are not even specks, and the stars themselves begin to blur together. We enter the realm of the spaces between galaxies. The distances from the Milky Way to other galaxies are, by all accounts, mind-boggling. They are chasms of nothingness that defy human comprehension. As a rule, the gap is measured not in kilometers, but in time from millions to billions of light years. And this space is not static, it is breathing. Due to the universe's cosmological expansion, the fabric of space itself is stretching. The distance between the Earth and any remote object in the universe is constantly growing. We are all drifting apart. This stretching of space affects the light itself. As a photon of light travels across these vast distances, the space it moves through expands, stretching the wave of light, making it longer. This stretching makes the light emanating from this object look redder than it actually is, shifting it towards the low-energy end of the spectrum. This phenomenon is known as redshift. It is the color of distance, the color of a universe that is running away from us. But it is not just a fading signal, it is a tool. It is of great help in gauging distances and velocities on the astronomical scale. A ruler made of light that helps us measure the breadth of the cosmos. While the expansion of the universe pulls most things away from us, painting them in the color of distance, the redshift, there is an alternative story written in the light. Sometimes, the cosmos brings things together. In rare and beautiful instances, a galaxy's spectrum is blue shifted. To an astronomer, this color is a signal of approach. It means that these islands of stars are not on an escape trajectory, fleeing into the void, but on the contrary, they are moving to meet us. It is a cosmic reunion, played out over millions of years. One of these unusual space objects, rushing towards us like a traveler returning home, is the galaxy known as Messier 86, or simply M86. It resides in the bustling neighborhood of the Virgo cluster, roughly 52 million light-years away from our Sunday. To us, that seems incredibly distant, yet, in the grand scale of the universe, it is our cosmic backyard. M86 is moving towards the Milky Way at a breathtaking speed of around 244 kilometers per second. This incredible velocity makes it one of the fastest-moving blue-shifted galaxies we have ever discovered. It is diving towards us, but this speed comes with a price. M86 is not moving through empty space. It is plowing through the heart of the Virgo cluster. This region is filled with scattered hot gas, a resistive medium that acts like a thick atmosphere. Imagine a runner sprinting through a heavy storm. The wind tears at their clothes. Similarly, by moving at high speed through this scattered gas, M86 is constantly shedding its own interstellar matter. The pressure of the cluster strips the galaxy of its gas and dust. As a result of this violent process, it leaves a trail behind it, long, glowing lines of warm, ionized hydrogen that stretch out like the wake of a ship cutting through a dark ocean. This trail tells a history of violence. M86 is connected with faint bridges of light to the almost destroyed spiral galaxy NGC 4438. Several of these filaments act as tethers between them. These two galaxies are thought to have collided at some point in the distant past, a high-speed crash that was the smaller one's undoing, shattering its spiral arms and leaving it scarred forever. Interestingly, M86 is something of a conqueror. It is known to have destroyed its other neighbors in the past as well. It is a survivor that has grown by consuming others. Several stellar streams, ribbons of stars that look out of place, have been detected in its halo. These are likely to be the ghostly remains of smaller galaxies absorbed earlier, their structures unraveled and woven into M86 like trophies. But perhaps the most impressive feature of M86 is its jewelry. An impressive number of globular clusters, dense balls of ancient stars, orbit within its structure. Observations show that their number is upwards of 3,800. To put that in perspective, our own Milky Way possesses only a fraction of that number. This count is around 25 times as many as we have at home. There is a theory that claims these clusters are not originally children of M86, but rather the remains of dwarf galaxies that M86 would have absorbed in the past. It stripped the core of these small galaxies, leaving only the dense clusters behind. If it really is the case, then M86 is a graveyard of sorts. It would have destroyed tens or even hundreds of other galaxies to build its massive collection of stars. Having said that, while M86 is impressive, it looks visually similar to many elliptical galaxies, a ball of light. However, the galaxy we turn our eyes to next looks anything but unique. It looks like a creature from the deep sea. The galaxy ESO 137-001 is a sight that defies the usual shapes of spirals and spheres. Located about 227 million light-years away from the Sun, in the constellation of Triangulum Australe, it is a massive structure, as heavy as 5 to 14 billion solar masses. As for its stars, most of them are young, bright blue giants, burning with a fierce, hot light. But it is not the stars themselves that capture the imagination. It is what the galaxy is doing. ESO 137-001 is not floating peacefully. In its turn, it is part of the Norma cluster, also known as Abell 3627, a large, dense galaxy cluster, and it is falling. It is moving to the center of this cluster at an incredible speed of almost 2,000 kilometers per second. At this velocity, the galaxy collides with the interstellar gas pressure inside the cluster. It is like facing a hurricane made of hot particles. As a result, its own gas, the fuel for future stars, is blown out of the galaxy. It is stripped away, streaming behind it in long, flowing ribbons. These tails stretch for up to 260,000 light-years a distance, more than double the width of our entire Milky Way. Incidentally, the mass of interstellar gas in those trailing areas is huge. It is 2 to 4 times that of the gas remaining inside the galaxy itself. The galaxy is bleeding its lifeblood into space. It is hardly surprising, then, that starbursts are a common thing here, but not in the galaxy, in the tails. That is, stars don't stop forming even as the gas is ripped away. In these enormous streams, made up mostly of hydrogen, new stars ignite, creating bright knots of light in the wake. When seen from the side, ESO 137-001 appears exactly like a giant jellyfish floating through the endless expanses of space. The main body of the galaxy forms the head of the jellyfish, glowing blue and bright, while the long tails of gas and young stars trail behind it like tentacles, drifting in the cosmic current. Unfortunately, this beauty is a sign of a slow death. As the galaxy is continuously stripped of its interstellar gas, its life expectancy diminishes too. The gas is the fuel. Without it, the fire eventually goes out. With not much material left inside the main body, no new stars can form here. This greatly affects the structure of the spiral arms and the central bulge of the galaxy, which will slowly fade and redden as the blue stars die out. However, on the bright side, this tragic dance gives us knowledge. Scientists have a chance of finding out more about dark matter, the invisible scaffolding of the universe, and its interaction with other space objects. By observing the behavior of the gas streams left in the galaxy's wake, seeing how they bend and hold together, we can map the invisible gravity that guides them. Speaking about the formation of newer stars, let us leave the dying jellyfish and travel to a place where the universe is screaming with life. There is a galaxy with a name that speaks for itself, the Baby Boom Galaxy. If our Milky Way is a quiet town where a star is born occasionally, the Baby Boom Galaxy is a bustling metropolis in the midst of a population explosion. Around 4,000 stars are born here every single year. Let that number settle in your mind. In our own Milky Way, we produce perhaps 10 stars a year. The rate in baby boom is about 400 times more than in the Milky Way. Straightforward calculations show that, on average, a new star lights up in this area of space every 2 hours. Imagine watching the sky, and before you could finish a long nap, a new sun has ignited in the dark. The Baby Boom Galaxy lies extremely far away, around 12.2 billion light-years away from the Earth. Looking at it is like looking into a time machine. This means that what we see when observing it is not happening now. We are seeing what was happening just 1.5 billion years after the hypothetical Big Bang. It was a time when the universe was still in its infancy, still in the process of forming its structure. What is taking place in that galaxy now, or rather, then, is drastically different from what we expect to observe there in theory. Based on what we know about star formation, galaxies in the early universe should be growing slowly, building themselves up piece by piece. But Baby Boom is a monster. The reasons why stars are produced here at such an astounding, frantic rate are not known yet. It challenges our models, but it is beyond any doubt that baby boom is able to provide us with a lot of information about the early, energetic stages of our universe's evolution. It reminds us that the cosmos was once a wilder, brighter place. Finally, we turn our telescope back to something closer, something iconic. One of the few galaxies one can observe through an amateur telescope, a favorite of backyard astronomers everywhere, is the so-called Sombrero Galaxy. Its official designation is M104. It lies about 30 million light-years away from the Sun, a friendly neighbor in the Virgo constellation. It is not a giant. Its diameter is roughly 4 times smaller than that of the Milky Way. But what it lacks in size, it makes up for in style. The Sombrero Galaxy's outstanding feature, the reason for its whimsical name, is a massive ring of dust and cold hydrogen enveloping it. When we look at it from Earth, we see it edge on. The bright central bulge rises up, and this thick, dark dust lane cuts across the middle, looking exactly like the wide brim of a Mexican sombrero hat against the bright background of stars. Observations show that it is here, in this dark brim, that most young stars are born, hidden within the dust. But, in addition to the peculiar ring, the Sombrero Galaxy is also remarkable for its elaborate inner makeup. It is a puzzle wrapped in a riddle. Observations with the Spitzer Space Telescope, which sees in infrared, show that most stars in this galaxy form a structure typical of elliptical galaxies, big, round balls of stars. The stars here are mostly rather old, yellow, and red dwarfs, ancient and quiet. However, the other stars here, on the other hand, form spiral structures concealed within this elliptical cloud. It is a galaxy within a galaxy. It is thought that this phenomenon, this hybrid shape, is a result of a major merger. It tells the story of 2 galaxies' collision, where a large elliptical galaxy swallowed a flat spiral one. Over eons, their stars subsequently and inevitably mingled together, creating this unique Russian nesting doll structure. It is incredible that the galactic structures survived a merger of that scale with minimal damage. They appear organized and elegant, are none the worse for this tremendous collision, and can still be observed as one of the most photogenic objects in the sky. But the Sombrero holds one last secret in its heart. Another peculiar feature in the Sombrero Galaxy is exceptionally powerful X-ray radiation emanating from the center. It is a beacon of high energy. It is assumed that the accretion disk of a supermassive black hole, a giant sleeping in the middle of the hat, may be its source. The mass of the hole is estimated to be over 1 billion solar masses, which makes this enormous object one of the most massive black holes known to science today. It anchors the entire galaxy, and yet the mystery deepens. There are also several sources of tremendously high-frequency radiation, known as terahertz radiation, detected within the galaxy. This is a type of light that is very hard to produce in nature. Although today, their nature, what exactly is singing this high-pitched song from within the dust, is still a mystery, waiting for us to listen closer in the quiet of the night. As our galactic parade draws to a close, we do not end with a shout, but with a whisper. We turn our gaze to one last island of light, a galaxy that watches the dark with a heavy, drowsy lid. This is the eerie Messier 64, known to stargazers affectionately, and rather aptly, as the Black Eye Galaxy. The nickname comes from a poetic trick of light and shadow, a spectacular, sweeping band of dark cosmic dust sits on the near side of the galaxy, partly concealing the bright glow of its center from the observer on Earth. It looks exactly like a heavy eyelid closing over a shining eye, as if the galaxy itself is drifting off to sleep. Because of this thick mask of cosmic dust, as well as the exceptionally bright, active nucleus burning behind it, it is impossible for us to estimate the black eye's number of stars, even roughly. They are hidden behind the veil. What we do know is that it is a cozy galaxy, comparatively small and not so remote. Its radius measures 25,000 light-years, and it lies approximately 17 million light-years away from the Milky Way, a close neighbor in the sprawling city of the cosmos. But beneath this sleepy appearance lies a secret motion. The Black Eye Galaxy is made up of two well-defined parts that are dancing to different tunes. Interestingly, the inner disk, glowing with the light of old stars, rotates in one direction, but the outer ring, filled with gas and dust, rotates in the direction opposite to that of the inner heart. Imagine a waltz where the dancers in the center spin left, while the circle around them spins right. It is a ghostly, silent friction. The most likely explanation for such a bizarre makeup is a memory of a cosmic embrace. It suggests that the galaxy formed after two smaller ones collided and merged in the distant past. One galaxy swallowed another, but the momentum of the victim survived, spinning forever in the wrong direction. Admittedly, it would take a combination of a number of mutually independent factors for such a fascinating and well-defined structure to form. For example, the progenitor galaxies would have moved at specific velocities and come together at a certain, precise angle, like two leaves meeting in a stream. The odds of such a success would have been minuscule, yet here it is, spinning quietly in the dark. And now, let us leave the islands of light altogether. Let us drift out of the galaxies, away from the fires of creation, and enter the deep, calm waters of the voids. Voids are large-scale expanses of space that are almost, or completely, devoid of galaxies or galaxy clusters. They are the deserts of the universe, vast oceans of nothingness. These enormous objects take up about 50% of the observable universe. If the universe is a sponge, the galaxies are the fibers, and the voids are the holes. The average void is a bubble of silence, measuring approximately 40 megaparsecs, or about 130 million light-years across. However, just as there are giants among stars, there are titans among empty spaces. The diameter of champion voids may reach several hundred million or even a billion light-years. These extra-large voids are rather predictably referred to as supervoids. The density of matter in these regions is much less than in other areas of the universe. It accounts for less than 10% of the average density in the meta-galaxy. Voids are the largest formations among the large-scale structures of the universe, standing on par with the galactic filaments or the thread-like formations that connect the stars. Cosmology today explains their existence by the diversity of matter when the universe was first formed, ripples in the primordial soup that grew into vast caverns of emptiness. One of the largest regions of silence ever discovered is the Canes Venatici supervoid, spotted by patient eyes in 1988. This supervoid is the second largest void known to science today, a sphere of solitude with a diameter measuring a staggering 300 to 400 megaparsecs, or a billion light-years. To understand where this lies, imagine traveling 1.5 billion light-years away from our Earth. There, you would find it. Interestingly, in this abyss, life is scarce. Just 17 galaxy clusters are located in this area of mind-boggling dimensions. Think of an ocean the size of the Pacific, with only 17 small islands scattered across it. This is extremely little for such an incredibly enormous expanse of space. All the 17 clusters are gathered within a comparatively small area by space standards, huddled together within a measly 150 million light-years. If any gravitational interaction between them does take place, it is a whisper too faint for us to hear. More advanced technologies are called for to detect it. The diameter of the Canes Venatici supervoid accounts for approximately 1% of that of the entire observable universe. It is a cavern so vast that it could easily accommodate 10,000 galaxies, identical to the Milky Way in terms of dimensions, stacked side by side. Yet, it is empty. Who knows? Perhaps there are life forms on a lonely planet hidden somewhere in these 17 clusters, looking out at a sky that is almost completely black. However, there is no way light from our sun will ever reach those parts, and any interaction with potential inhabitants of those parts of the universe is effectively out of the question. We are separated by a sea of time. Now, pause for a moment. What is a billion light years? It is a number easy to say, but hard to feel. Let us measure it in life. The history of multicellular life forms on our Earth, starting from the primitive, jelly-like coelenterate animals floating in ancient seas, counts just over 800 million years. In other words, life on our planet evolved from colonies of simple protozoans to fish, to dinosaurs, to mammals, and finally to humans, all in less time than it takes a photon of light to travel from one edge of this supervoid to the other. It takes some stars less time to complete their entire life cycle, from getting born in a nebula to going supernova or finishing life in an alternative way than it takes to cross this emptiness. Actually covering this distance in a spaceship, romantic as it is, sounds like a recklessly eccentric idea. It is a journey for the mind, not the body. In order to understand what space inside a void is like, you have to think of a deep physical vacuum. It is the ultimate stillness. It may contain wisps of interstellar gas clouds, independent star clusters, or even lonely galaxies. But most of the supervoid contains nothing. The name is self-explanatory. Of course, space expanses are for the most part vacuum, but here, the vacuum is profound. Just to give you an idea about the proportions, imagine a single cubic centimeter of dense stellar matter. To match that mass, you would need thousands of cubic kilometers of this empty space. But even this space is not completely empty. Nothing in the universe is truly empty. Consider our home. A mark of 100 kilometers above ground is the accepted limit of the Earth's atmosphere, the edge of space. At this height, the atmospheric pressure is so small that it becomes comparable to that of the solar wind. However, there is no clearly defined transition to space. The air just gets thinner and thinner. Even several hundred kilometers above the Earth's surface, where satellites drift, there can be found an extremely small amount of gas molecules from our atmosphere. Seemingly negligible, these molecules still manage to caress the metal skins of spacecraft, slowing down artificial satellites orbiting our planet. As a result, many of them have to regularly adjust their orbit, firing small thrusters in order not to lose their momentum and not to have to get back to Earth prematurely. Gas concentration is much lower the further we are from a planet. But even beyond our solar system, and away from any star or planet, there will always be at least a few molecules of hydrogen in every cubic centimeter of space. In addition to that, there will be the solar wind in space, a current of high-energy subatomic particles emitted by the sun, like a breeze blowing through the trees. And of course, other things have to be reckoned with, like the faint radiation of distant stars, the ancient relic radiation from the Big Bang, and neutrinos, subatomic particles particularly hard to detect that pass through us like ghosts. But the vacuum inside the void is deep, to such a point that the concept of empty takes on a new meaning. There is less than half a molecule of matter for every cubic centimeter of space. It is a solitude so complete that the mind can barely grasp it. Besides, all sources of radiation, the stars, the galaxies, are so remote from its center that the density of their radiation is quite negligible compared to the relic radiation. As a result, all that remains in this dark cathedral is undetectable neutrinos and the cosmic microwave background, the humming afterglow of creation. As I've mentioned before, there is something else to be found inside the incredibly vast expanses of the void, hidden in the dark. Apart from the deep vacuum, there are also clouds of interstellar gas, cold, waiting, the future nursery for stars and galaxies that have not yet been born. Secondly, the mysterious dark matter is supposed to be found inside supervoids, holding the structure of the nothingness together. But today's methods of detection are hardly adequate for studying it. It remains a shadow in the dark. It should be noted that the overwhelming majority of voids detected so far are located hundreds of millions of light-years away from the solar system. We are looking at history. In essence, what we are observing now is the distant past of these formations. But silence can be closer than we think. Only one void lies relatively close to the local group of galaxies, our home address, which includes the Milky Way. This is referred to as the local void. It is our neighbor in the dark. Its diameter measures approximately 180 million light-years, and the distance between the Sun and the void's center is about 90 million light-years. We are sitting on the porch of a great emptiness. Then there is the Boötes void, another large formation about 700 million light-years away from the Sunday. It is often called the Great Nothing. The diameter of this void measures approximately 330 million light-years, a bubble that accounts for about 0.27% of the diameter of the observable universe. The Boötes void was discovered in 1981 by a group of scientists headed by Robert Kirshner, confirming what was once only a guess, with theoretical arguments in favor of the existence of supervoids having been formulated 20 years previously. This supervoid is thought to have been formed as a result of several smaller voids blending together, like soap bubbles merging into one large sphere. It is a lonely place. Just 60 galaxies have been pinpointed inside the Boötes void by now. To understand how empty that is, consider that such staggering expanses, if they were normal space, could easily have accommodated about 2,000 galaxies. Instead, it is a vast, dark room with only a few flickering candles. And finally, speaking about the most mysterious void in the universe, we look to a place that chills the very fabric of space. It lies 3 billion light-years away from the Sunday. It is known by many names: the CMB cold spot or the Eridanus supervoid. This supervoid is a champion even by supervoid standards. It is a colossus with a diameter measuring 1.8 billion light-years. It is a hole in the universe so large that it may easily have accommodated 18,000 galaxies similar to the Milky Way, yet it remains barren. But what makes it truly special is its temperature. It is a ghost that breathes cold. The Eridanus supervoid's temperature is from 70 to 150 degrees microkelvin, colder than the average CMB temperature of the universe, colder than anything the standard models predicted. This chill is so profound, so inexplicable, that even the most robust tapestries of knowledge we have woven about the universe's origin cannot give a definite explanation to this fact. It stands as a silent anomaly. This data so completely did not fit into the accepted theory in cosmology that, at first, the measurements were dismissed. The silence was too deep to believe. The scientists thought their instruments had failed them, that the equipment was faulty, or that some earthly noise had interfered with the celestial song. It was only after several years of scrupulous measurement, checking and rechecking the heartbeat of the sky, that the readings were finally accepted. The cold spot was real. Since then, a great number of explanations have been whispered in the halls of science, including rather extravagant ones concerning these strange temperature properties. One hypothesis suggests that this is not emptiness as we know it, but the result of the influence of supermassive chunks of dark energy, great unseen tides pushing the fabric of space apart, creating a valley in the density of the universe. But there is another story, one that borders on the fantastical. According to another hypothesis, this area is a bruise on the skin of our reality. It is suggested that this cold spot is what is left of a collision, a gentle brush against another universe that had existed before ours, or perhaps one that floats alongside us in a multiverse. It could be the fingerprint of a reality beyond our own. Be it as it may, there is, surprisingly and somewhat disappointingly, no definite answer yet. The universe keeps its deepest secrets well, and perhaps that is the beauty of it. The diversity of space really has no limits. In the visible part of the universe alone, there are hundreds of billions of galaxies, from the shy dwarf ones hiding in the shadows to the gigantic elliptical masters that light up the dark. Each of them contains billions of stars, from fierce blue giants to the gentle, cooling brown dwarfs. There are planets we can only dream of, and countless smaller bodies drifting between them. Each of them is unique in its own way, a singular masterpiece of gravity and time. And this means that our journey across the boundless expanses of space is quite endless. There will always be another star to visit, another mystery to ponder, another quiet corner to rest our eyes upon.